Objective 3.4, solving radical and rational exponent equations. So last lesson we looked at graphing the square root and cube root, which are the most common uh, radical functions that we will be graphing in this class. Now we want to take a more algebraic approach, and we want to look at how we solve equations that have radicals or rational exponents in them. So that is our objective for today, is to be able to solve those equations that contain radicals or rational exponents. One piece of vocabulary that's going to be helpful to us is the powers property of equality, which states that if A is equal to B, then A to the nth power would equal B to the nth power. So saying in other words, you can raise each side of your equation to the same power and your equation will stay equivalent. Another thing we're going to have to watch out for as we solve these equations is the occurrence of extraneous solutions. These are trial solutions that seem like they might work, and yet when you put them back into the original equation, you discover that they do not actually satisfy the original equation, they do not make it true, and therefore you cannot use them as a solution. So they come up originally as a possibility for a solution, but then we realize that you cannot actually use them as a solution. All right, so in the first example, we want to look at taking some simple roots. And when we're working with problems like this, our goal is always to try to get first the part of the equation that we're taking the power of, get that isolated, and then ultimately get x isolated. So in this case, that would require us to divide both sides by 6 first, which means x cubed will be equal to negative 216. And then we are ready to take the root. So the root needs to match the power so that they will cancel each other out. So since this was x to the third power, we need to take a cubed root of both sides. And since we are taking an odd root, you'll remember from one of our previous lessons that there's only one possible real answer to this. And in this case, we find that 216 is a perfect cube, so that's going to be 6. And because it's an odd root, having a negative inside of the radical is not a problem. It's quite possible to take negative 6 times negative 6, which would be positive 36, but then take it times negative 6 one more time to get a negative 216. So x equals negative 6 is our solution. In this case, it's not just our variable that's being taken to a power, but it's a whole expression. It's the binomial x minus 4 that's being taken to the 4th power. So in order to isolate things, our power piece of the equation already is isolated on the left side. So in order to get to the x, we're going to have to start by taking the 4th root of both sides. And again, that root needs to match our exponent. So that on the left side, the 4th root and the 4th power will cancel out and leave us with just x minus 4. Now notice on the right side, we end up with a plus or minus 3. This is because we are now using an even root with a number inside the radical which is positive. So again, going back to our previous lesson, we know that an even root, when we have a number inside that is greater than 0, and when we take the root as a step in solving an equation, we have to consider both the positive and the negative possible answers. So just like with our square roots, any even root, we have to have plus or minus when we evaluate that. And now to get x completely by itself, we would add the 4 to both sides, and then we would simplify. So our positive 3 plus 4 gives us an x value of 7, and our negative 3 plus 4 gives us an x value of 1. And if we put both of these back into the equation, we'll find that they do both work, and so both solutions are real solutions to our equation. All right, why don't you try a couple? You have two equations here. Pause your video for a moment while you work them both out, and then come back when you're ready to check your answers. All right, so in the first case, we can divide both sides by the negative 5, which will leave us with x squared equal to 6. And then since the square is even, taking the square root will be an even root, and we get x equal to plus or minus the square root of 6. In the second equation, we need to take the cube root of both sides so that we just get x plus 4 equal to 3, only the one answer because it's an odd root, so it's just 3. And then when we subtract the 4 from both sides, we get x equal to negative 1. All right, now let's move on to equations that have rational exponents in them. So here we have the equation x to the 5/2 power equals 32. Now our goal is still to get x isolated. We want to get x by itself on one side of the equation equal to an answer on the other side. But how we do that with rational exponents is a little different. If we're trying to get x isolated and get x all by itself, then we're assuming that we want to get x with an exponent of 1. So we have to think, how do I take this x to the 5/2 power and create a situation where I could make that into x to the 1st power? And if you think back on some previous algebra, you may come up with the idea that I can multiply 5/2 by its reciprocal to get 1. Now what do I need to do with exponents so that I end up multiplying the exponents together to make that happen? Well, what I need to do is take the power and raise it to another power. So the x to the 5/2 I started with, I'm now going to take that to the 2/5 power so that I will end up multiplying reciprocals to get 1 for my exponent. And using the power equivalent property that we saw in our vocabulary, if I take the left side to the 2/5 power, then I need to take the right side to the 2/5 power as well to keep things equal. So we can now see that our 5/2 times 2/5 gives us the 1, so x to the 1st power on the left side is just x. And now the 32 to the 2/5 power on the right side needs to be evaluated. So we go back to our definition of what a rational exponent means, and we realize we need to take the 5th root of 32, which will give us 2, and then square it because the 2 is in the numerator. So 2 squared gives us an answer of 4. And if we want to go back and check, putting 4 in for the x means we're taking 4 to the 5/2 power. Well, the same thing. The 2 tells me I need to take the root of 4, so that's going to be 2, and then I take that to the 5th power, and it does indeed give me the 32 that I have in my equation. Okay? So in this case, we need to get our exponent term isolated first. So that's going to mean adding the 2/5 to both sides. And here, if I multiply by the reciprocal is simply 3. Because remember, if we are taking x to the 1/3 power, that means the same as taking the cube root of x. And so it makes sense that we should be cubing both sides as the way to get rid of the exponent on the left side. So taking the 1/3 times the 3 on the left will leave us with just x. And then taking the 2 and cubing it will give us 8. Taking the 5 and cubing it will give us 125. And so we end up with x equal to 8 over 125. In this case, in order to get the exponent piece isolated, we're going to need to divide by 4 first. So that's going to give us x to the 3/4 equal to 27. And then we're ready to raise each side to the exponent that is the reciprocal of the exponent we started with. So x to the 3/4, we want to take that to the 4/3 power. That also means taking 27 to the 4/3 power, and then we can evaluate that number. Cubed root of 27 is 3. 3 to the 4th power gives you 81. So our x value is 81. Now here again we have a situation where it's a binomial that's being taken to the rational exponent. So we already have the exponent piece isolated, and the way to get rid of the exponent is still the same. We're going to multiply by the reciprocal, which means taking it to the power of the reciprocal, and in this case that would be 2. So we're going to square both sides. Now when I do that, what I'm left with is 2x plus 5 equal to the 4 squared, which is 16. And then I just continue to solve until I get x completely by itself, and that would give me 11 halves. And again, each one of these you can put your x back in and double check that it really does work. Alright, why don't you try a couple now that you've seen a few. Pause the video for a moment while you're trying them, and then come back when you're ready to check your answer. Alright, so in our first equation, we're going to need to divide both sides by 5, and then raise both sides to the 2/3 power, and that should give us an answer of x equal to 4. In the second equation, we would want to subtract the 7 first to get 2x to the 1/2 equal to 18. Then we would need to divide by 2 and square both sides to end up with x equal to 81. Now, in our next example, we're going back to looking at equations with radicals in them, but this time we need to be careful about extraneous solutions. They may show up, they may not, but it's always a good idea to double check your answers and make sure they really work, because extraneous solutions, those answers that look like they should work but really don't, very easily can show up when you're dealing with equations that have radicals in them. So in this case, I would want to cube both sides first to get rid of our cubed root. That's going to leave me with x plus 40 equal to a negative 125. And then I would subtract the 40 to get negative 165. Now if I put this back in for x, negative 165 plus 40 gives me the negative 125. And the cubed root of negative 125 really is negative 5. So this one works just fine. How about for this one? If I add the 13 to both sides, I'm going to get the 4th root of 2x equal to 4. Then I would take each side to the 4th power, to get 2x equal to 256, and then divide both sides by 2 to get x equal to 128. So again, if I substitute this in, 2 times 128 is 256. The fourth root of 256 is 4, and 4 minus 13 is negative 9. So this one also works. Let's try this one. We've got the square root of 6x minus 5 plus 10 equal to 3. I need to subtract the 10 from both sides so that I can get the square root completely by itself. Then, based on our previous problems, we can square both sides to get rid of the square root and end up with 6x minus 5 equal to 49. Now I can add my 5 and divide by 6 to end up with x equal to 9. But when I put that back in, 6 times 9 gives me 54. 54 minus 5 gives me 49. At this point, because I am just evaluating, I am not trying to solve the equation anymore. I've already done the solving. I am just evaluating things to check the equation. So when I take the square root of 49, I'm only interested in the positive 7. And if the positive 7 is the only answer I get, then my left side ends up being equal to 17, while the right side is only equal to 3. So since x was the only solution I got, but it doesn't actually work, all I can put for this equation is that there is no solution. Now you may have been able to recognize this a little bit sooner in the problem if you notice that right here we ended up with a statement that said the square root of something was going to end up negative. That's not possible. To take an even root of something, it has to give you positive answers. You can never get a negative answer when you're just evaluating that. So if you recognize that issue in a step like this, you can immediately say there's no solution right here. But sometimes we miss that, or sometimes we just don't realize that that's the case, and so it's always a good idea to make sure that you're really checking your final solutions and make sure that they really do work. Okay, so give these two a try, see what kind of solutions you come up with, and make sure you check your solutions to see if any are extraneous. When you're ready to check your answers, come back to the video and we'll finish up with our last example. Alright, so in the first case, we're going to subtract the 2 from both sides and then cube both sides to get x equal to negative 8. When we substitute negative 8 back in, it really does work, so it's fine. In our second equation, we're going to add the 5 to both sides first. Then we're going to divide by negative 1 because of that negative out in front of the square root of x. And that's going to end up being the square root of x equal to 1. So squaring both sides gives me 1, and everything works out just fine. So both of these have solutions that really do work. Now, another place where we very often get extraneous solutions is in situations where we have variables on both sides of the equation and the equation deals with radicals or rational exponents. So here's an example like that. We have x minus 12 equal to the square root of 16x. Since I have the square root on the right side, the first thing I want to do is to square both sides. Now keep in mind on the left side, that means squaring the entire x minus 12 binomial. And remember, that does not mean x squared minus 144. You need to FOIL that all out to get x squared minus 24x plus 144. And then on the right side, our square and our square root cancel out, and we have 16x. Now what I'm dealing with is really a quadratic. So I want to subtract my 16x to the other side and get everything equal to 0 so that I can use quadratic methods for solving this equation. Now I just happen to notice that I can factor this into x minus 34 and x minus 4. If you don't notice that, you could always go to quadratic formula or some other method to solve this equation. But in this case, factoring does work, and I end up with two possible solutions of 36 and 4. But when I go to put both of these back in, with the 36 minus 12 gives me 24. And when I put 36 in for x on the right, taking the square root of that will also give me 24. So the 36 is fine. But with the 4, if I put 4 in for x on the left side, I end up with a negative 8. And when I put 4 in for x on the right side, the square root of the 64 gives me a positive 8. So the 4 does not actually count as one of our solutions. Only the 36 actually works and can actually be written as the solution to this equation. So 4 was an extraneous solution, and we should not include it in our final answer. How about this one? We have the square root of x squared plus 5 equal to x plus 3. Again, keep in mind that when I get rid of my square root by squaring, I have to square the entire right side of x plus 3. So I end up with x squared plus 5 on the left, and I end up with x squared plus 6x plus 9 on the right. Now, if I try to get everything on one side equal to 0, you'll notice that my x squares actually cancel out, and I'm just left with a linear equation. 0 equals 6x plus 4. So now I can solve for x by subtracting 4 and dividing by 6 and making sure that my answer is in lowest terms, which would be negative 2/3. Now when I put this back in, it does actually work, and so negative 2/3 really is my answer. So go ahead and give these two a try. These are our final examples for this lesson. When you're ready to check to see how you've done, come back to the video and we'll wrap things up. Alright, so in the first equation we would want to square both sides. That's going to end up giving us a quadratic equation, and we end up with solutions of 1 and 3, and both actually work. So we would keep both 1 and 3 as our solutions. In the second equation we would also square both sides, but this time our quadratic gives us a 9 and a negative 1. The negative 1 is actually extraneous, so only the 9 should be written for your final solution. Alright, that should get you through our next set of practice problems in Objective 3.4. Make sure you are checking your answers as you go to see if you have any extraneous answers, and then also check your final answers with the answers on Canvas to make sure you're getting them right. If you have questions as you go, make sure you find the necessary resources to answer those questions. If there's any issues or problems, shoot me an email. I'll try to get to it as quickly as I can. And our next thing on the agenda should be a quiz. So make sure you're taking a look at your practice quiz and preparing for your quiz after this lesson. And we'll see you next time.